The purpose of this experiment is to understand the relationship between applied load, deflection, and the span of beams. So we are going to use this setup. What you see here is a simply supported beam subjected to a concentrated load at midspan, and what we are going to do is measure the deflection at midspan, compare the measured values with calculated values. We are also going to look at how the measured deflection changes as the loading is increased, and also how the deflection changes when the load is kept constant but the span changes. And we are going to use 4 different beams, each made of a different material, to try to derive the modulus of elasticity using the measured deflections and the relationship between deflection, modulus of elasticity, inertia, applied load, and span. So in theory of structures, you derived a relationship between deflection at midspan and the applied loading, modulus of elasticity, moment of inertia, and span. In your manual, you will see this expression for a simply supported beam as delta equals load times span cubed divided by 48 times modulus times I. So we are going to consider all these different scenarios and use the values of measured deflection and compare them with the theoretical values that you would get using that relationship.
This is experiment 6, deflection of simply supported beam. This is the test setup. We have a displacement transducer, 4 weights, loading device, and 4 specimens. The 4 weights we have are 100, 400, 500, and 900 grams. The displacement transducer must be set vertically, oriented downwards. Once a specimen is set on the test device, use the screws on the right to tighten. The 4 specimens are as follows: pure copper, brass, galvanized steel, and aluminum. Measure the length of the copper plate. Set the span length as 50 centimeters. Place the copper plate on top of the test device. After making sure the span length is 50 centimeters, tighten the screw on the right. Please make sure that the bottom part of the test device is secure and cannot be moved easily. Make sure the span of the specimen is 50 centimeters. After the specimen is set, move the loading device to the midpoint. Then move the displacement transducer directly on top of the midpoint. Next, carefully place the loading tray on the loading device. Then set the transducer to 0. After everything is set, slowly unhook the loading tray. Add 500 gram weight and slowly attach it to the loading device. Note the readings on the transducer. Do not attach the loading tray too quickly, otherwise it will be hard to read the numbers on the transducer. Minimize movement when attaching it. Add another 500 gram weight so that the total is 1000 grams. Note the readings on the transducer. Now set the total weight to 1500 grams. And note the readings on the transducer. Repeat the same process with all the other plates, using 1500 grams. When finished, place the aluminum plate on the test device. Set the span length as 50 centimeters and the loading device at the midpoint. Place the displacement transducer next to it. Attach the loading plate and set the transducer to 0. Add 1500 gram weight to the loading plate and carefully attach it. Note the readings on the transducer. Unload the device. Unscrew the screws and change the span length to 40 centimeters. Set the transducer to the midpoint. Tighten the screws at the bottom. After attaching the weight tray, set the transducer to 0. Add 1500 gram to the weight tray and attach it. Note the readings on the transducer. Next, change the span length to 30 centimeters and 20 centimeters. Repeat the same process by adding 1500 gram to the weight tray. When finished, unload the testing device and remove the transducer.